Hello everyone. So our today's topic is hyperconjugation or Baker-Nathan effect, or it is called as no-bond resonance. Because of hyperconjugation, the electron or the compound gain more stability. And to show hyperconjugation, the conditions are: in the molecule there should be one alpha carbon. And it must be sp3 hybridized. Okay, alpha carbon, see, this is your alkene. Now, which one is alpha carbon? You can consider this also alpha carbon, this also alpha carbon. डायरेक्टली जो कार्बन डबल बॉन्ड से अटैच होगा वही आपका अल्फा कार्बन होगा. Okay, so hyperconjugation is delocalization of sigma electrons of CH bond of your alkyl group. Generally, hyperconjugation is shown by your carbocation free radical this is your free radical symbol, this is your carbocation and alkenes. Now first let's see in carbocation. Now let's see hyperconjugation in carbocation. This is your carbocation. Now you can see this is your alpha carbon and this is sp3 hybridized. This is I will show you how to find out the hybridization also, but it's a 3-4 sigma bonds, so this is hybridized. Now let's see. This is your carbocation. How your sigma electron can be delocalized? By this arrow, you will show hyperconjugation. आपका sigma electron transfer होना, this sigma electron goes there and the sigma electron is here. Now इसने sigma electron लिया है, it will be negatively charged. It will be positively charged. Now ये इलेक्ट्रॉन तो ट्रांसफर यहीं पर रहेगा, पर आपके और जो बाकी सिग्मा इलेक्ट्रॉन्स हैं वो डिलोकलाइज होते रहेंगे. Okay. This is delocalization of the sigma electron, which we are explaining by hyperconjugation. Now, the examiner can ask you questions like total number of hyperconjugative structures involving CH bond breaking. Now, you can say your total number of hyperconjugative structures involving CH bond breaking are equal to number of alpha H present. As you can see, here are your 3 alpha H. Alpha H are those hydrogens which are attached to your alpha carbon atom. So here will be 3 hyperconjugative structures. Now let me show you some examples. How many alpha carbons are there? Tell me. आपके पॉजिटिव चार्ज से डायरेक्टली अटैच्ड कार्बन एटम आपके अल्फा कार्बन एटम होंगे, या फिर नेगेटिव चार्ज से, या फिर जैसे भी फ्री रेडिकल वाले कार्बन से अटैच्ड आपके कार्बन एटम अल्फा कार्बन एटम होंगे. दिस इज योर अल्फा कार्बन एटम, दिस इज योर अल्फा, दिस इज योर अल्फा. Here are 3 alpha H. Here 3 alpha H. And here 2 alpha H. Here total number of hyperconjugative structures is 3 alpha hydrogen, 2 alpha hydrogen plus 3 alpha hydrogen. That is 8. 8 alpha H means 8 hyperconjugative structures are there. Okay. Let me show you one more example, that is here is your plus charge. Now tell me how many alpha carbons are there. This is your alpha carbon, this is your alpha carbon, this is your alpha carbon. Here 3, here 3, here is 1. 7 alpha H. Now this is tricky. Tell me how many alpha hydrogens are there, or alpha carbon are there. You must be thinking there are 4 alpha hydrogens, 3 here, Sorry, 5, 2 here. No, it's it's only alpha carbon. Alpha carbon must be sp3. This is not your sp3. This is sp2. Here 3 alpha H only. Let's turn to the next. That is your alkene. Now here, this is your directly double bonded carbon atom. This is your alpha carbon. Alpha hydrogens 3. Let me take you through more examples. Now shift the sigma electrons. Total hyperconjugative structures are 3 because here are 3 alpha H involving CH bond breaking. Now the next example is in free radicals. होमोलिटिक बॉन्ड ब्रेकिंग से बनता है आपका फ्री रेडिकल कहलाता है. समझा चुकी मैं आपको पहले. Let me show some examples. This is your free radical. This is your alpha carbon, which is sp3 hybridized. Now I can show the delocalization of sigma electrons. Here bond fission will be homolytic. So here positive negative charge will not be generated because एक बॉन्ड में 2 इलेक्ट्रॉन थे. एक इलेक्ट्रॉन यहाँ पर शिफ्ट हुआ है और एक इलेक्ट्रॉन आपका यहाँ पर शिफ्ट हुआ है. सिग्मा इलेक्ट्रॉन्स. हमने ये वाला बॉन्ड शिफ्ट करा है. सॉरी. This is your free radical. Now your hyperconjugation increases the stability of the molecule, more will be the hyperconjugative structures, it will be more stable. You must be thinking why we are studying hyperconjugation. Let me show you some examples. How many alpha are there? Directly attached carbon is one alpha H. sp3 hybridized. Here are your 4 alpha H. Here are your 3 here, 2, 2, 3 plus 2 plus 2, 7 alpha H. So 7 hyperconjugative structures. And this will be the most stable among these. Okay, now you must have understood what is hyperconjugation, why we are studying it. Now let's see orbital overlapping approach in hyperconjugation. Orbital overlapping approach. And the very first example is carbocation. How you will show its orbitals. This is your carbocation. Now here overlapping is, this is your hydrogen. This is your vacant p orbital. Okay, as you know, carbon have one vacant p orbital. Okay, this is your sp3 hybridized carbon atom. अब बॉन्ड जो आपने बॉन्ड ट्रांसफर दिखा है वो एक्चुअली ऐसे होता है. दिस इज योर carbon's orbital and hydrogen's orbital. Now here sigma p overlapping is taking place. Vacant p orbital of carbocation and sigma of sp3 hybridized alpha carbon atom. Hope you understand. Alpha of sp3 hybridized carbon atom and between vacant p orbital. Vacant p orbital. Now free radical. Now let's see orbital overlapping approach in free radical. Free radical. This is a free radical. This is your hydrogen orbital. These are having overlapping. In free radical and carbocation, orbital overlapping is almost similar, but in carbocation it was vacant p orbital. Here it is half filled p orbital. You can say the overlapping is between sigma and p orbital. Sigma, of course, sp3s. हाइड्रोजन में केवल आपका एक ऑर्बिटल है 1s2. It is sp3s and half filled orbital of half filled p. P orbital. The overlapping is between sigma and p. Now see, this is your alkene. अब आपका यहाँ पर डबल बॉन्ड इंट्रोड्यूस हो गया है. अभी तक आपने सिंगल बॉन्ड से देखे हैं. लेट्स सी. CH. Here is your one sigma and one pi. Pi looks like this, and it will look like this only. This is your sp3s. The overlapping is between sigma and pi star. Sigma of course sp3s, pi star of your alkene. There are some special points about hyperconjugation. You must be thinking alkene में hyperconjugation हो रहा है. Here is double bond. Let me share some hyper. Does not exhibit in your carbonyl in your cyanide group due to high energy of your pi star orbital. Due to high energy, the delocalization of electrons from sigma to pi star is almost impossible. So it can't show hyperconjugation. Hyperconjugation increases the stability of your carbocation, stability of your free radical, stability of your alkene group. Let me show you with some example. Compare stability. This is your carbocation. Which one is most stable? Here are 9 alpha H, 3, 3, 3. Here 6 alpha H. Here are your 5 alpha H. This is the most stable. More hyperconjugative structures, more is stability. There is a term which is called as reverse hyperconjugation. No one will ask you questions from this, but you should know what is reverse hyperconjugation. Reverse hyperconjugation is delocalization of pi electron to vacant orbital. And for reverse hyperconjugation, you must have alpha x. Alpha x. Alpha x means halogen. This is your example of reverse hyperconjugation. Here your electrons, sigma electrons transfer like this. This can be transferred, this can be transferred, this can be transferred. So it will look like, see, if you will transfer this sigma electron, then if you will delocalize is the right term. This is your hyperconjugative structure. If you will delocalize this electron, then it will be like how I could do this mistake. Carbon can't have 5 bonds. Okay, and this, if you will delocalize this sigma electron, then it will be like in reverse hyperconjugation, electron delocalize from CH3 to alpha carbon. Hyperconjugation, there was condition to have alpha H or alpha carbon for hyperconjugation. For reverse hyperconjugation, molecule should have alpha X, that is X attached to your alpha carbon, which is sp3 hybridized carbon atom. So this is all about your hyperconjugation. I hope you understand this topic. If you have any doubt, can ask in the comment section. Definitely I will answer. Thank you for watching.